Next up is partial fractions, okay? Partial fractions. Do you remember those? Yeah? If you don't remember them, pause the video now, okay? And just have a quick flick back through the partial fractions unit. But I'm not about to recap the whole thing to you, okay? It was on page 9, okay, in your textbook. It was a long time ago, and we probably did it at the end of year 12. Do you remember that? End of year 12 seemed a long time ago, didn't it? Okay. Yeah, we're going to do partial fraction with integration. Okay, so I'm going through the examples, page 310, okay, example 20, part A, and that's it on the board there. So integral of x minus 5 over x plus 1, x minus 2. Okay, you need to be able to recognise when to use partial fractions as a method of integration, just as you need to be able to recognise when to use substitution, by parts, and all the inspection questions we did as well. Okay, what makes this chapter not only long but difficult and challenging as well is that there's a lot of different types of integrals you've got to kind of get used to, and you've got to put it all together, and when you get given a question in the exam you've got to know what to do. Several exam questions actually help you out a little bit. Some of them say part A, write this as partial fractions, part B, integrate this, in which case I pretty much told you how to do it. But suppose they say integrate that, you've got to know it's partial fractions. The thing to look out for is if you've got a fraction, obviously, but if the denominator will factorise, okay, the denominator will factorise into linear terms like that, x plus 1, x minus 2, then it's always partial fractions. Okay. Now, the partial fractions bit normally takes up a fair bit of board space. Okay, and to be honest, what I do in class anyway is I skip the partial fractions bit because, well, for starting class I've got less time. Okay, I'm trying to get through the hour lesson or however much I've got, but also because I ask people to know it or just to go back and recap. Okay, what I've done though is earlier I produced this. Okay, and just make sure that you can see that very well clearly. Yep, good. So you've got x minus 5 over x plus 1, x minus 2. Write that out as a over x plus 1, b over x minus 2. See the next line? Hope you're happy with that. Pause the video, of course, anytime you're feeling unhappy with that. X equals 2 gives you b is negative 1, x equals negative 1 gives you a equals 2. Okay. So what I'm going to do is I'm going to write that as the partial fractions. So that will be integral of, and then that will be a over x plus 1, so 2 over x plus 1, like that. And then it's b is negative 1, so subtract 1 over x minus 2. Okay, so 2 over x plus 1, subtract 1 over x minus 2. Happy with that? And then let's just make this line correct, shall we? Integrate that dx. Okay, so a little bit of working to get from this line to that line there, okay? Once you're done, I'm hoping you know how to do that. You should know how to do that, okay? Joking aside, you should know how to do that already, okay, from the previous work. So this here is going to be 2 natural log x plus 1. Yep. And this one here is going to be subtract natural log x minus 2. Yeah. Okay. I'm not about to recap that with you. Go and look at one of the really earlier videos I did. Okay. Or just look at the textbook. Okay. I'm going to put plus c, but I'm going to change it in a minute. All right. So maybe if you've taken note of this, you don't write the plus c yet, but I just want to keep that constant in mind. Okay. The thing is, we can simplify that, and often we're asked to simplify it. You might be asked to write your answer as one single term. Well, that isn't it, is it? That's 1, 2, 3 terms. You might be asked to write your answer in terms of a single natural logarithm. Well, of course, that's not it, because that's 2 natural logarithms. That's not even a logarithm at all, is it? Okay. So what we're going to do is we're going to see how we can combine these. So remember your natural log rules, or log rules, using natural logs and all this. So you can write that as natural log of x plus 1 squared, can't you? Yeah, like that. Okay. Do we need the bob brackets? Not anymore, because the squared implies it's going to be positive anyway. Okay, and then subtract natural log x minus 2. Now, if we're going to combine all these terms and make one single term, the plus c is a bit awkward because it's not a natural logarithm. So what instead I'm going to do is I'm going to write it like that, plus natural log of k. K has been chosen because obviously if I write natural log c, it's not the same as that. You've got to make sure that you recognise that constant there. I'm just rewriting it as natural log of k. And I can combine all these terms together now. Okay. So the multiplication rule for this and this, because you're adding them, so it's going to be k times that. And then the division rule, because you're subtracting this. So what we're going to have is natural log of, and it's going to be x plus 1 squared multiplied by k over x minus 2. And we'll put the modulus brackets in like that. Okay, I'm just going to check to see how the textbook has written it. Because, yeah, as I thought, I mean, if you're on page 310, they've written it with the plus c on the end. That is better. Okay, that is better. Because a little bit later on, we're going to be solving differential equations as well. Which means, well, put long story short, we have to work out what the constant k is sometimes and substitute the value of x. And it's often easier like that. So try and be in the habit of writing like that if you can. Okay? Is that okay for you? Good? I'll do another video in a minute. The videos are too long if I do all these examples one at a time, so that's why I'm pausing after each one. Okay?